Okay, so we've got another type of factorisation here that we are looking at. And as with previously, it is represented by the reverse of an expansion that we've done. So let's take an expansion that we've done before. X minus 3, x plus 3. Alrighty, so what we've got there is we can do our four-step method, our first, outside, inside, last, or however you're thinking about it. But what we end up with is x squared plus 3x minus 3x minus 9. And what we end up with is x squared minus 9. It's one of those situations where the terms in our brackets are the same, but with different signs. So what will happen is these two terms in the middle will be equal but opposite. So we'll end up with two squared terms. We end up with x squared minus 3 squared. So if we turned around and wanted to factorise something that looks a little bit similar to this, we could employ the fact that we know if we've got one square term being subtracted from another, we're going to have a set of brackets that looks something like this. So let's say I want to factorise something like this, y squared minus 25. Okay, well I've got y squared minus 5 squared. That's my two square terms. One square term being subtracted from another. I'm subtracting 5 squared from y squared, so I end up with y and 5, y and 5. Y plus 5 and y minus 5. Okay, they're the same terms with the opposite signs in between the brackets, and we could expand that out to check that we got back straight up to here, y squared minus 25. I won't, but you can if you would like. But this is our factorised form. Okay. That means that it's fully factorised right there. Let's have a look at another one. So I've got b squared minus 64. Okay, well I've got b squared and I've got minus 8 squared. Again, the two things that go into my brackets, b minus 8, b plus 8. Doesn't matter whether we have b minus 8, b plus 8, which one comes first doesn't matter, as long as we've got b first in the brackets. We can't have 8 minus b, 8 plus b, because b squared is the positive term, 8 squared is the negative term. What if I've got something like this? X squared minus y squared. Alright, well, following our same pattern, we know the terms that are going to go into our brackets there, and their signs have to just be opposite. X plus y, x minus y. So if you see a set of terms and you're asked to factorise them and there's only two of them, more than likely it's going to be a difference of two squares, unless they shared a common factor, in which case you would just do what we did in our very first video with using common factors. Let's try a couple that might be a little bit harder. Okay, let's say I've got something like this. 25 minus 9 p squared. All right, well, the important thing for this type of question is to look at it and say what terms are being squared. What multiplies to give 25? That one's easy, it's 5 squared. Minus, well, what multiplies itself to give 9p squared? The temptation here is to say, well, it's just p being squared. Yes, that's true, but what multiplies to give itself, or 9 is what square number? It's the square of 3. So we've got this. So what has to go into my brackets is whatever is being squared. So I've got 5 plus 3p, and I've got 5 minus 3p. So that's the sort of thing we're talking about, where it's a little bit harder, where it's not just a standard term. What about something like this? If I've got 2 a squared minus 2. Okay, well, we've got a little issue because 2 is not a square number. But what we can look and say is that they share a common factor using that same method we did earlier, just that nice simple, what factors do they share? They share a factor of 2. Everything else goes inside. But now we can look at this bit here and say, well, I can actually factorise that. That's a squared minus 1 squared. I can put that squared in there because 1 times 1 is still just 1. And what we'll end up with is our 2 square terms going in the brackets, obviously with opposite signs, and we end up with 2a plus 1, a minus 1. Now, if you ever see two terms, we go and we look for common factors. And once you have dealt with any common factors, or if there are no common factors, you're looking at a difference of squares. Okay, so our other factorization methods won't work on this. So we're looking for a difference of two squares. Just thinking about it from our last method where we're looking for sum and product, let's say I've got something nice and basic like this, x squared minus 16. Well, pretend like it is x squared plus 0x minus 16. Well, what numbers multiply to give minus 16 and add to give 0? Well, they're going to have to be the same number, 4 times 4, but one will be positive and the other will be negative. That's just another little explanation as to why this method works. It still kind of falls under the branch of we're doing a trinomial. We've got three terms looking for our sum and our product, but it's obviously a special type of that, so we can do it a little bit quicker way.